Hey guys, welcome to day 8 of programming every single day until I graduate college. I'm still planning on some project ideas. I still haven't been able to check out what I wanted to build. I'll probably start on it. I'll be probably like working on some ideas, kind of how to build it and stuff. Maybe throughout this week. Um, and then I'll jump into like showing the code and coding it during these series. But kind of preparing for school because I start soon. So more Leetcode, and I still want to be kind of interview ready just in case anything pops up. But it seems like most internships are kind of closed. So, but I'm trying to keep it very simple, or keep myself fresh and ready. But either way, we'll just do another Leetcode. Let's do task scheduler. I'm almost done with task scheduler. I mean, heaps, which is nice. I've never solved this problem. This sounds fun. I don't know. We'll see. But let's read it. Let's see the percentage. It shouldn't be too bad. 60% isn't terrible. So I should be able to solve something. You're given an array of CPU tasks, each labeled with a letter A through Z and a number N. Each CPU interval can be idle or allow the completion of one task. Task can be completed in any order, but there's a constraint. There has to be a gap of at least n intervals between two tasks with the same label. Okay. Return the minimum number of CPU intervals required to complete all tasks. This is some kind of like low level simulation or something. Not sure exactly what this means, but we'll see how this kind of works out. A, B, okay. A, B. Okay. Let me just have this in my editor. So, I think we can have a solution. I just gotta understand what this is. So we get an array of strings, or array like characters of what is it, A to B? It can be any. Okay. The possible sequence is A, B, idle, A, B. So we can have two consecutive and then idle. Okay. After completing A, you must wait 2 intervals before doing A again. The same applies to task B. In the third interval, neither A nor B can be done, so you idle. Okay. By the fourth interval, you can do A again as 2 intervals has passed. Okay. So you could just do A, B, C, D, A, B. Okay. And that would be just basically kind of the length of this. Okay. I'm curious on how a heap would come into play here. A, B, idle, A, B, idle, A, B. Damn, this is a pretty tricky. I'm not really understanding what it's asking here. Possible sequence is A, B, idle, A, B, idle, A, B. A and B, which need to be separated by 3 intervals. This leads to idling twice before. This is an interesting one. There are only two types of tasks, A and B, which need to be separated by 3 intervals. Since the idling twice between repetition of these tasks. After completing task A, you must wait 2 intervals before doing A again. So I guess N is some interval, right? You're given an array of CPU tasks, each labeled with a letter from A to Z, and a number N. Each CPU interval can be idle or allow the completion of one task. Each CPU interval can be idle or allow the completion of one task. Tasks can be completed in any order, but there's a constraint. There has to be a gap of n intervals between. So at least between 2 tasks with the same label. Curious on how a heap would work. I'm not sure what this n number is. There's 2 intervals before doing A again. The same applies to task B. Let's just try to re-understand this. So we have A, B idle, A, B idle, A, B idle. That's kind of the answer, but what is this number? What does it mean for 1, 2, 3, 4, 5, 6, 7, 8? Okay. With the letter from A to Z. Okay. And number n. Each CPU interval can be idle or allow the completion of one task. And I assume you have to go. Tasks can be in any order, but okay, they can be in any order. So I don't have to go by A, B. But there's a constraint. There has to be a gap of at least n intervals between 2 tasks with the same level. Okay. So I can't go A, because... Okay, so... This is considered 2. Okay. A, B... So it's A, B, or something like that. After completing a task A, you wait 2 intervals before doing A again. The same applies to task B in the third interval. Neither A nor B can be done, so you idle. By the 4th interval, you can do A again as 2 intervals pass. I'm gonna do some experimentation. I'm curious on how a heap would work, right? Oops. Right. I'm gonna I don't know if I'm allowed to name this actually. Tools. Maybe I'll do this. And then just always have from tools. Okay. I'm curious on what happens with this. Of course, I gotta sort it or print it. Now, it takes some time to understand it. So hold on, let's see what happens when I so it stayed. Well, this is in a sense sorted, right? So it's not gonna do anything. But I'm curious what happens. Let me I think there's a tool. I think there's some kind of method I can call. Heap. I think just pop it. Never mind. Just pop. Pop. Yep. And I'll do this while. Does not equal 0. Let's do that. Does it return anything? If it does, that'd be nice. I don't think so, because I think it does like an in place. So I'll just print the current state of. Oh, let's check. Wait, hold on. Whatever. Let's just oh, what's going on here? Okay, like this is the normal state, and then popped. I'm curious what let's see what this does. I assume it's doing some kind of lexicographic thing here, because I don't know what 100% alphabetically, which is nice. A heap we could use it to keep here, and I assume though it's this A is the smallest. Okay. I have some kind of idea here. Maybe we can keep track of two heaps. One that's a min heap and one that's a max heap. And we pop alternatively and include some idles as we fit based off that constraint n, right? Would that make sense? Like, okay, after I pop A, I need to do like B, right? A, B, A, B. I would do that essentially. Would that make sense right here? A, B, C, D, A, B. Exactly. I see a pattern here. I'm seeing the conclusion. This is great. I'm noticing like it's like if there was a max heap, of this and a min heap, and if I alternate between those two, essentially that's what you're drawing out, right? A. But obviously that runs into issues of like duplicates. I don't want to print out multiple out of them, but so A, B, interesting. I'm curious on what this like, how this is supposed to like play. So I think two heaps, but not necessarily two heaps, but there's got to be some sort of alternating of two different heaps or something. Because look, they already noticed something here, right? I'm going off the ends of each things here, right? I wish. Interesting. Maybe I can keep two heaps of the same array, but one is. I guess two heaps wouldn't be bad, but as I move from small heap, I also have to remove from max heap and vice versa to keep the duplicates out of the way, right? I think that makes sense. So I can do like two heaps. One is a max heap, one is a min heap. Yeah. What could I do? So all I just want is like a reverse of this. Would my guess is like what would happen? Could the lowercase version of this be the perfect way to kind of get the opposite, right? So let's test that out, right? I'll have task 2, and just I'll have this the lowercase. And I'll just grab this. Oh, it's fine. And let's see if it still might be alphabetical. I'm curious on how I can convert to two. So, oops. I think we do. So like heap q dot heapify tasks. Okay. This is exact same. Well, hold on. Yeah. If I added a Z. And then put the Z at the end. Well, okay, hold on. I assume it's doing it alphabetically. Maybe is there some parameter I can like look up heapify? Python. Is there some parameter I can look up? Oh, reverse true. Hold on. I'm curious on how I could do like a max heap with freaking characters. Is there like a reverse equals true or something? I gotta change it. Yeah, I gotta change this. Yeah, I gotta change this. I gotta, it's like a reverse. Oh. Okay, I guess not. It just takes in one parameter. Yeah, this takes one. No. I don't know how to use zero-based indexing that makes the relationship between the nodes slightly less obvious, but it's more suitable since Python uses zero-based indexing. Our pop method returns the smallest item, not the largest. To create a heap, use an initialize I'm curious. I don't know. But do I really need necessarily a heap? Kind of. Or I can utilize and largest and smallest with the same heap, and I actually preserve. I preserve the same list as well. So let's see. What is considered n largest and returns a list with n smallest elements from the data set defined by iterable. The latter two functions perform best for smaller values of n. I don't know. It seems like, hold on. Well, obviously, was it heap q dot heapify task one? Well, that's it, and then heap q dot n largest task. I don't know. Do I put a number? Yeah. I don't know. I don't know what this n is. Like an integer or something? I don't know. Task one. Hopefully that key is optional. And there's print. If it returns, I can print. Oh my goodness, that is exactly what I wanted. Yes. This largest is Z, and the smallest is. Okay, then this makes your life a little easier. Then I think I have some kind of plan here. Let's actually just write some stuff out. Well, here's the thing. I feel like I'm not understanding the problem here, right? We do A, B, idle, idle. Like right here, like A, B, idle, idle, A, B, idle, idle, A, B, idle, yeah. Like A, B, and then we have here A, B, C, D. Like A, B, C, D, A, B. I feel like I'm not, this might not work, but I think it's worth a shot since I'm kind of coming up on time. Okay. Well, I know that I can get like n largest and smallest by alternating like I need to do like while I guess the I don't know task what is my condition here though? I don't know what should be my it's really unclear, so I'm gonna say while true for now, and of course I'll heap q the heapify task, and that's good. While true and task dot I guess some kind of CNT right here, right? Counter. So like we do. Here's the thing. I should do heap q dot n smallest task. We have largest and so like 1 2. Okay, I see what it means. This is 1 1 2 3. Then you can go. Oh, okay. And then here is 1 2. So it's 1 2 3, and then you can go. Okay, okay. Is there some mathematical formula I can put? Instead of a counter, I can probably just have an array. And then just return the length of res. Right? If true, then do this. Elif true val then what do we say? Idle. Something like that, right? That makes sort of sense to me, right? Like that's kind of how I'm envisioning it. Yeah, I guess. I just don't know what the condition would be, right? Wait, and then obviously we have to do. I see some very much repeated code. So these are. I see. You know what? We'll do this. If something else is true, then and then just res dot append the val. That's a bit cleaner. I think I just need to figure out what the heck is the condition to break, what is the condition to add it, because I don't know what it like. There's probably some math formula that I can deduce. So we can have some kind of counter. So if we're gonna keep track of some number, then the index is probably important. So I can have like some counter here, right? Right, and maybe it's fine. This is 0 plus 3. Oh, I see. So if it's essentially 0, so if it's 1, it's basically odd, even. If it's 2, it's offsetted by 2. So in the third interval, neither A nor B can be done. So you can, I know. Okay. Yeah. So A is done. B is done. Maybe some kind of double flag for, but that just assumes we have like I can't do a flag for every single character, you know. It doesn't sound realistic. So yeah, it's a cooling. So A is done. So we have to cool for at least 3 times. So 0 plus so yeah, we can just cool like A plus so if you're divisible by the number, then it's, I don't know, is A, so like 1, 2, 3. Here's the thing. This is only gonna be for, I don't know, 2 values. Yeah, it's coming up time. I can't really think of a really good solution. Maybe I could visit the hints here. There are many solutions. A greedy algorithm for every cycle prior to Q. I don't know. It's kind of tricky here. I'm very curious on how it's like brute force. Max heap. Is there a min heap? Greedy. Math. Let's do the max heap. I was starting to think of that. Like some kind of like I was struggling to figure out like the struggling to figure out the thing itself, which was the offset. Like I wasn't able to figure out the offset, so that's unfortunate. But let's see how they're doing it. Right here we have count here and the counter of some kind of frequency and then a max heap. It keeps a keeps a priority queue of the occurrence of this. It's like 3 and 3, and then max keeps it. Okay. Okay. Max heaps it, and then time, and returns the time. Uses a dequeue instead of heapify. Okay. Oh, wait, that's not true. Some prior queue. So while the max heap is still truthy and the queue is still truthy, pairs of count and idle time. We'll increment the time. If not max heap, if it's falsy, then take the queue and the first index. Interesting. Else, take the create a variable and the most highest one, which would be negative now. Interesting. If it's not 0, basically, if it's truthy, then append the C and T and this. If the Q and the I guess this or something, this goes to the time, then push. Yeah, this is a pretty confusing, very confusing solution. I'm gonna try to see if there's a solution for this.
Hey everyone, welcome.
What?
0, once a task becomes...
I see. What are some of the other solutions? Greedy, let's see. Some counter, that's nice. And then sort it. I see. I guess this is a fail for today. I will write down the solution and then retry it again next time. Yeah, let's see. So we have count equals counter, create occurrences, and then create a max heap. And then this is the confusing part. We take the time of push the max heap of the value of this. Very, very interesting. But yeah, that was my attempt at it. I'm gonna revisit this next time. Since I looked at the solution, but I promise I'll try to find a project by the end of this week and we'll work on that for these videos. But for the meantime, I'll probably do a bunch of Leetcode. But yeah, anyways, thanks for watching.